For Chapter 10, Section 2, we're going to continue to talk about simplifying radical expressions. We did a little bit of this in Section 1, but we're going to extend on it some more and talk about how we can also, within the same expression, have two separate radicals and how we can combine them or split them apart if we need to, and how we can work on simplifying them to get your final answer. So remember when we talked about rational expressions for the first time in Chapter 10, Section 1, that we went over kind of how to figure out like what the root is, like what the index is, and kind of how those can go back and forth. So when you're dealing with something raised to a power, written like this, b raised to the m over the n power, the n is going to be the index of the radical, so that's going to go on the outside. M is going to go with the b on the inside. So a lot of times when we first started talking about this, we only saw all of our terms being raised to like the 1/2, the 1/3, the 1/4 power, and we were just dealing with a singular index, and there was like a 1 inside the radical sign, but we didn't really do much beyond that. Well, now you're going to start to see things where you have terms underneath the radical sign that have exponents, and then you also have a different root on the outside of the radical sign. So I want to go over how you take care of something like that. For example, you might see something that looks like this, where you have 36 raised to the 3/2 power. So when you write that with a root, you're going to have that square root. So there's technically a 2 here, but remember when we have those square roots, we normally don't write the 2. 36 is then raised to the 3rd power. So if we wanted to simplify this, we would take 36 to the 3rd power, and that got us this 46,656, and then you're taking the square root of that, which is 216. Another thing that you could have done instead is you could have the square root of 36, all of that raised to the 3rd power, so you could do the square root first, instead of expanding out the 36. So the square root of 36 would be 6, but then that has to go to the 3rd power, and you still get 216. So you can see that you got the same answer for both of those ways. So you can decide how you want to approach dealing with some of those radicals, but sometimes depending on how big of a number you're dealing with, it might be easier to go one way versus another, just because you're dealing with some large numbers. So I want you guys to go ahead and practice doing this on your own. So rewrite these as radical problems and then go ahead and simplify them. So when you did these, you could have done either method that I showed you up above as far as how you want to write it. Sometimes I feel like the second way I showed you is a little bit simpler just because it lets you deal with smaller numbers, so you're not having to deal with such large things like when you're on your calculator. So for 27 to the 4/3, I'm going to rewrite that as the cubed root of 27. And all of that is going to be raised to the 4th power. So I did the cubed root of 27 first, which would be a 3. And then 3 to the 4th power would simplify to 81. For this practice problem, we would do the 4th root of 16. All of that's raised to the 3rd power. The 4th root of 16 is going to be a 2. So then you have 2 to the 3rd, which would be 8. All right, so let's remember back in Chapter 7 when we were talking about dividing polynomials. When you were dividing and you were able to simplify, we needed to make sure that our bases were the same, so like you were dealing with the x's, the y's, the z's, whatever, and then you could work with their exponents a little bit. When we're dealing with square roots or any type of radical sign, your index has to be the same in order for you to make one fraction. So if you need to write yourself that note, that number on the outside of the radical sign, those have to match in order for you to combine this as one big problem. So another way to think of this is that you have to have like radicals. So they both have to have cube root signs, or they both have to have fifth root signs, something like that, in order for you to be able to combine them and then reduce the quantities that are underneath those symbols. So for example, I have square roots here. I have the square root of 162y to the fifth over the square root of 3y squared. So because they're both square root signs, I can make this one big square root and kind of create that fraction underneath. And the benefit of this is because now I can reduce the stuff underneath the square root sign before I try to pull anything out. So what I did next is I looked at my numbers. So on top I had a 162 and a 3, and I divided those to get my 54 here. And then with your letters you have y to the fifth and y squared, so you're going to subtract those exponents to get y to the third. So remember, 5 minus 2 is how we simplified those exponents. Now what we would have done is try to reduce your 54. So again, like we've done in the past, you can kind of factor tree 54 and look for a group of 2. So remember, 54 would be like 9 times 6. 9 would be 3 and 3. 6 would be 3 and 2 if you're doing your factor trees. Well, I only need one group of 3, so these 2 3s from the 9 could be my group, and so that's why this 3 came out front. The other 3 and 2 here that I had left over have to stay underneath the square root because there's not another 3 or another 2 for me to be able to group them with to pull out. So that's why we left that 6 underneath the square root sign. Now as far as the letters go, remember from section 1, I can break y to the third apart. So they broke that into y squared and a y. And so when you take 2 divided by 2, you get 1, so that's where this y came from. And the other y has to stay underneath the square root sign. So this is your simplified answer right here, 3y and then the square root of 6y. So we're going to kind of be combining the things that we did in last section to this new idea where you're able to simplify your square roots underneath, like dealing with those numbers like you would just algebraically using division, and then start reducing your radicals by looking for those groups like we did in section 1. So go ahead and try to simplify this one. So because they're both regular square roots, we can go ahead and combine this as like one big problem. So we have 50 x to the 6 over 2x. So 50, I'm going to divide that by 2, would be 25. And then for my x's, the top one has a 6 for the exponent, this bottom one has a 1, so 6 minus 1 would be 5, so that would be 25x to the fifth. Now for 25, we can factor tree that into 5 times 5. There's your group of 5. So like we did last section, you could have written it like this, 5 squared. And then for your x, 5 is not divisible by the 2 that's sitting out here. So I'm going to break one x off, so it says x to the fourth times x. That way I can divide that 4. So the square root of 5 squared would be a 5. That would just come out. For your x to the fourth, you're going to take 4, divide by the little 2 that's technically sitting out here, so that becomes x squared. So that takes care of those terms. This x, we can't divide the 1 that it has by that 2, so that has to stay underneath that square root sign. Alright, so let's extend this a little bit further now, and let's get into some other types of roots that you might see, and then also we'll kind of start to see some of these problems where we're not able to reduce as is like we could on those last ones, and so we have to kind of break our terms apart before we can do any reducing. So for example, I have this big cube root, and underneath it I have 5x squared all over 12y squared z. Now if I try to reduce stuff right now, nothing will reduce. Like I can't reduce the 5 and the 12 at all, and I don't have any common letters inside of my square roots. So what I need to do is break this apart into like 2 separate square roots. or cube roots, I should say, for this one. The problem is that when you're dealing with fractions, you cannot leave a radical sign in the denominator. You have to have the bottom be radical free, so it can't have a square root sign or a cube root sign or anything like that. So in order to clear the denominator, we have to somehow get all of these terms in the bottom to become perfect cubes. So in order to clear the denominator, everything for this problem must be a perfect cube. Now if it was a square root, then everything would need to be a perfect square. Okay? So how we do that is we take a look at what's in the bottom and we try to figure out, like, what do we need to include or add to the radical so that it will clear, so that it'll simplify and we won't have it anymore. So we're looking at the bottom, and I've got my 12 here, and so if I think about like factoring it, this would be 4 times 3, for example, and 4 would be 2 and 2. Well, I don't see any groups of 3. So I'm looking at my factors here. I've got 2, 2, 3, and then I still have that y squared and z. I don't have any groups of 3 in order to clear the 2's or to clear the 3, so I need to add a couple of things in order to get me to be able to clear them. So you need to ask yourself, like, if you look at this, how many 2's do you see? 2 of them. How many more would you need to get to 3? 1. So you can see how they multiplied by 1, 2 over here. That way it'll become a group of 3, and we'll be able to get rid of that denominator, the radical sign out of the denominator. Now, for the 3's, you only have 1 3, so I would need 2 more in order to get that to be a group of 3. And then we do the same thing with our letters. Like, how can I get these exponents to become 3's? What do I need to add for my letters in order to get them to reduce? So y squared, I would have to take that times a y to get y to the third. And z I would have to take times z squared in order to get that to become z to the third so that I can get rid of that cubed root underneath the bottom. Now, because I'm multiplying the bottom numbers by these in order to get that radical sign to clear, I also need to make sure that I'm doing it to the top as well. I can't just do it to the bottom because that would leave this problem unbalanced. If it's helpful for some of you, think about what's going on here when you're multiplying. So like underneath the cube root on the top, you've got that 5, and then you've got a 2 and 2 3's. And then for your letters, you have 2 x's, a y now, and 2 z's. So I'm just combining the top portions here. And then I can do the same thing with the bottom, and on the bottom you should see all those groups of 3 that we were trying to create. So I have 3 2's, 3 3's, 3 y's, and 3 z's. So then what's going to happen, if you rewrite this as 2 to the third, 3 to the third, y to the third, z to the third, is on the bottom, the 2, the 3, the y, the z, all of those are going to come out, which you see right here. They have the 2, the 3, the y, and the z, which they then simplify to 6yz. Now on the top, we're not going to have those groups of 3. So what we're going to do is just multiply the terms that we see together, and then if there's any reducing that we could possibly do, we could try to handle that as well, the same step. So underneath the cube root on the top, we would do 5 times 2 times 3 times 3, which is how they're getting this 90. You got x squared, a y, and a z squared, and so that's how they got that top portion. So we simplified this radical as much as we could. The main goal there was to get rid of that cube root sign in the denominator, which we did. And then on the top, you just multiply your terms together to see however much you can combine. So I want you guys to go ahead and give this practice problem a try. So pause the video, figure out what you need to do to your problem in order to get rid of that square root sign on the bottom, and then go ahead and simplify it. And then when you're ready to see the solution, you can resume watching the video. So this one is a square root, which means that I want groups of 2. So on the bottom, I only have a 3. So I need to add another 3 in order to get 3 squared. So that would be my group of 2. I have a y, so I'm going to multiply by a y to get that to become y squared. For my z, I have z to the third. I want to get the 3 to become an exponent that's divisible by 2. So if I add a z on, that would get me up to z to the fourth, and 4 is divisible by 2. So I multiplied the top and the bottom by this 3, y, and z. So on the bottom, I would start to see my groups of 2. I'd have 3 squared, y squared, z to the fourth. On the top, I would have a 5 times a 3, an x, a y, and a z. And so the last thing I need to do is just try to simplify by multiplying my terms together. So on top, 5 times 3 would be 15, and then x, y, z. On the bottom, all those are groups of 2, or the exponents with the letters are able to be divisible by the 2 out here now. So a 3 would come out, a y would come out because it would be y to the first, and then z, you would take 4 divided by 2 to get z squared.